We have the function f of x equals 2 plus f squared root of x. And also we have as information that delta x is equal to 1, and it is from 0 to 4. And with this, we are using to calculate the area the left-hand calculations.
Yeah. Well, the first step for solving this problem by left-hand calculations is to graph the function we have. For graphing, we're gonna take the values we already have, like 0 to 4, and after we put them, we make these shapes to be able to get the area of the parts we need for solve the problem.
To get the values, we're going to replace the numbers of the left side of the intervals, and we're going to replace them in the original function, which is 2 plus square root of x. And we've got these values. Okay, to get the approximated area, we're going to use the numbers of the left side of the intervals, and we are going to replace these numbers in the original function. So when we replace them, we got these values, and these values we need to multiply them by delta x, but delta x is 1, so these numbers keep the same. And the sum of these numbers is going to be the approximated area using the left hand calculations.
To prove that our answer is correct of our problem 2 plus square root of x, we also made this method. So first we get the antiderivative of this function, which gives us 2x plus 2 over 3x to the 3 over 2. Then we substitute on 4 and on 0. So as you can see here, 0 cancels. So we only have this. That will result the area of 13.33 units squared. In conclusion, we got that the result of our approximated area, that was our actual problem, was of 12.14 units squared. And in our verification using definite integrals, the area was of 13.33 units squared. So if we compare both areas, we got that the result is very similar. And so remember that our problem was to get the approximated area, so we can conclude that our problem was successful as our result.